Now I'm going to solve this example that we have in the center. Uh, it's the same from the last video, but I'm going to, from the last example from the last video, and I'm going to solve it in a different way. I'm going to use something called a U substitution, which is a very powerful method for solving integrals and antiderivatives. So let's start. So you have to basically pick something. You have to use an extra variable to reduce the complexity of an expression, to reduce it, to transform it to something very simple. So I'm going to use a u, which is a variable. That's why it's given this one. That's given the name to this method, but actually you can use any letter. It will be u. I'm going to name u to be this 3 times x. So u it's equal to 3 times x. Now here I'm going to take the derivative of this expression. The derivative of this expression, in order to find something that we can use to substitute for this dx. So this is a function that if you look at it in a way, you have, for example, y it's equal to 3 times x. It will be, this expression will behave just as this y. You take a derivative of this expression for y, this would be y prime it's equal to 3 times x. Now, another way to write y prime, it's just, you could write it like this. dy over dx is equal to 3 times x. Y prime and dy over dx is just the same thing. So you can actually write it this way. But the thing is, we can use this expression to manipulate it to our convenience. And it's going to look like this. So u will be our y, like in this case. So the derivative of u would be equal to du over dx. It will be equal to 3. The derivative of 3 times x is just 3. Now the thing is, we can manipulate this expression in order to find something that we can use to substitute in here. So I'm going to manipulate it to solve for dx. So if I multiply dx in both sides of the equation, this expression, we will get to this du it's equal to 3 times dx. Now I'm going to divide both sides of the equation by 3. So it would be du over 3 it's equal to dx. Now we can we know this 3 times x is going to be u, and this dx is going to be du over 3. The thing is, our goal here is to, every x in the expression that we are starting with, in this case, we have to find a way to transform every piece of x to a piece of u, basically. So this antiderivative will look like this, would be e to the u times dx, which we just found. It's going to be du over 3. Now this expression, I'm going to continue down here. This expression, this 1 over 3, we can put it outside of this antiderivative, and it will look like this. Like this. Now what we're going to use here as a reference, if you take, for example, I'm going to do it here on the right. If you take the derivative of e to the x, its derivative will be e to the x as well. Now, if you antiderivate e to the x dx, the result would be, again, e to the x, now in this case will be plus e. So this u, in this case, works just the same as this x we had on the previous, I just explained. So the integral of e to the u is just the same as the integral of e to the x in this case. So it will look like this. This 1/3 will be multiplying the result. 1/3 times e to the u be plus c. Now the thing is, as we started with terms of x, we have to unsubstitute this u, and at the end you will have this 1/3 of e to the 3 times x plus c. Now, as you may remember, we got to the same result as the previous case. Now, this was a lot of steps to do something that was actually very simple. But the thing is, this u substitution could be used in such a way that will solve a lot of cases with this principle, that you transform something that's complicated into something very simple that you can solve quickly. So Well, basically that's the idea for this use substitution. Let's see how to use it with more cases.